Taming the Giant. Electricity is important for the quality of life, and just as important for industry. Transformers play a key role in the distribution of electricity. They match the voltage and current to the particular needs. Siemens is a leading supplier of transformers and shunt reactors throughout the world. We have delivered well over 100,000 of them, in every shape and size, to more than 123 different countries. For example, Joshua Falls in North America, a 600 megavolt ampere bank of single-phase auto transformers for the 765 kilovolt transmission to Virginia. 575 megavolt ampere phase shift transformers near New York. They optimize the power factor in a 345 kilovolt grid. 125 megavolt ampere power transformers for the Creux de Chipie in Switzerland. Or shunt reactors and converter transformers for Africa's largest hydroelectric power station at Cahora Bassa in Mozambique. These ensure a reliable 533 kilowatt high voltage DC link to Johannesburg, 1,400 kilometers away. Many of our transformers are hardly audible, like the 350 megavolt ampere grid coupling transformer near Augsburg, with its separate bank of radiators, no louder than a beehive. Siemens power transformers are built right round the globe. In Germany, Portugal, Brazil, Colombia, Pakistan, China and Croatia, precisely to the customer's requirements. We manufacture generator and grid transformers with power ratings up to 1500 megavolt ampere and more, and voltages up to 1500 kilovolt. Grid coupling transformers, special purpose transformers, arc furnace transformers in a steelmaking plant with currents of up to 80,000 amperes. Converter transformers for major industry, for example, aluminium smelting. Locomotive transformers, specially developed for the ICE high-speed train, compact and reliable. Shunt reactors are used to protect the grid against surges. Siemens is a world leader here as well. Transformers with a tradition. Siemens began making transformers in its Nuremberg factory as long ago as 1912, a pioneer in the field. This one followed 2 years later, a 1 megavolt ampere generator transformer with 10.5 kilovolt high voltage. Siemens has many decades of experience. Our transformers have set standards and continue to do so. In the 30s, we built the first 100 megavolt ampere mobile transformer. In 1942, there followed a 1.6 megavolt transformer for an experimental overhead transmission line. In the late 50s, Siemens developed the transformers for the 400 kilovolt grid. In 1971, Siemens built the prototype of a 1.2 megavolt grid coupling transformer for UHV transmission. In those days, it bore the brand name Trafo Union. And in 1974, the world's largest 50 Hz generator transformer. Its rated power was 1020 megavolt ampere, a lot for those days. ever higher power and voltage ratings. That's always been a feature of our transformers. Nuremberg is the center of expertise for all our production plant. Our strong point is producing transformers specially matched to the customer's requirements, from the planning stage to commissioning.
The lower side. Red color and you can always
Production coils are wound on the cores. Depending on the customer's requirements for loss and noise levels, we use high B laminations or laser and plasma treated laminations. Laminations up to 6 meters long are built up into cores on special staggering benches. The step-lap staggering method offers the optimum solution in terms of low noise and electrical losses. The windings are produced in special clean areas. Layered windings made of stranded conductors are normally used on the low voltage side. The insulated conductor is wound one layer at a time under constant pressure and tension. Coils for high and very high voltages are wound on vertical winding benches in the form of continuously wound disc coils, or else as single coils. Then the windings are dried under constant pressure in large vapor phase drying ovens. The tank contains the active parts of the transformer and also the insulating oil. The total weight can be enormous, often several hundred tons. Many tanks are self-supporting. The base plates are up to 50 millimeters thick. The finished welds are tested using a non-contact fluorescence method. High resistance to corrosion is particularly important if transformers are to last well. Water-based paint is used as standard. If maximum corrosion resistance is required, then we apply an environment-friendly zinc dust coating. Afterwards comes a test for paint quality. This is the core of a three-phase transformer. It weighs about as much as a jumbo jet on takeoff, a good 300 tons. It's set up using giant maneuvering equipment. Then we assemble the active components, clamping devices, and on-load tap changers. When the active components are dried out using the vapor phase method, up to 1,000 liters of water can evaporate. The core and coil are inserted in the tank. Several hundred tons have to be positioned to the nearest millimeter. After final assembly, the tank is evacuated, filled with mineral oil and tested. Our quality management system accompanies all the production steps, from design and development via production right through to the final checks. Before the transformer is handed over to the customer comes the toughest test, the electrical and mechanical quality check in our accredited test fields. Here we test transformers and shunt reactors with rated powers of up to 1500 megavolt ampere and line voltages of 1500 kilovolt. Process computers control the measurement of noise level, electrical discharge and temperature rise. The test procedure is accompanied by a chemical analysis of the transformer oil. We can carry out all the relevant measurements in our modern materials testing lab. For example, furan analysis using HPLC. Low noise levels with high reliability and cost effectiveness. That's where Siemens power transformers score. Safe transport to the final destination. The route and the logistics have to be worked out in every detail, even before a transformer is designed. In Nuremberg, we can organize things to best advantage, whether by road, rail or water, or a combination of them all. Safe arrival at the destination is the prime objective. Then comes site erection and commissioning. The connection techniques used depend on local conditions. The most frequently used method is open-air connections. If space is at a premium, a cable connection is the most suitable. For high-voltage transformers in built-up areas, we prefer a direct SF6 encapsulated connection. We guarantee our customers trouble-free operation for many decades and around-the-clock maintenance service. Siemens monitoring. Our engineers are always coming up with bright ideas. If our customers request it, we equip our transformers with our new monitoring system. The principle is to move away from regular maintenance intervals to maintenance on demand. That saves operating costs. For example, using fiber optic methods, we can even measure the temperature at the center of a winding. In future, the superconducting locomotive transformer will become standard. It saves weight, but above all improves the efficiency from 90 to 97%. We know what our customers expect, and we match up to their expectations. Efficient, dependable, and a pleasure to deal with. We bring the power to where it's needed.